Okay, here's our 10.1 lesson. As you can tell, my voice has not gotten any better, so hopefully I'll be able to make it through this video. There are a few definitions that we need to know first. So this lesson, 10.1, is about inverses of simple functions, specifically quadratics and cubics, but we're going to talk about how to find the inverse of anything. You know a lot of inverses already. You may not know that you know them, but you do. So let's just review some important vocabulary. And the first thing, I need you to remember what a function is. So a function is a set of points where each input has only one output value. If you were in my class last year, we talked about how a single person can only go to one place at a time, or multiple people can go to the same place, but one person cannot go to two different places. If that doesn't make any sense to you, then don't worry about it. I'm just kind of trying to pull that back if you remember that explanation. And then the second definition that we need to know, this is the new one for today, is what an inverse is. And an inverse is a function related to the original, and it's found by switching the x and y coordinates. So for example, if we had y equals 2x, then the inverse of that, I would switch my x and y coordinates. So it would read x equals 2y. And then we still want to be able to kind of solve that for y. So I would divide by 2. And I'm kind of flipping where I've written this. Is going to say y equals x over 2. These two are inverse functions of one another, and they will write the original function in function notation. So they'll say like f of x equals 2x. Inverse notation has a little negative sign, -1. So the inverse of x equals x over 2. If you've had geometry, you might recognize this -1. Remember, you had to use that when you did sine, cosine, and tangent. So just recognize the big things you need to get from this slide. You need to have the two definitions, and then you may want to just jot this little example down and tell yourself specifically what the two notations are so that you recognize which one is the original function. So original is here in blue, and then which one is the inverse function. All right, let's look at an example. Okay, so here they want us to find the inverse and then state its domain and range. Remember, domain are your x values, range are your y values. So for the original function, I'm going to go ahead and do that first. F of x equals 0.5 x squared. If you had a calculator and you graphed that, it would look something like this. So if we were to state the domain there, all x values are valid. There's no number that I can plug in for x that won't work. I can plug anything I want to. So my domain here is all real numbers. Remember, another way to think about that is that these arrows go up and out forever. So if they're going to go out forever, they're going to hit the whole x-axis. That's why it's all real numbers. And then my range, it's going up forever. I'm thinking about my y values, but the lowest y value is down here at 0. So my range is y greater than or equal to 0. So now let's look about finding the inverse. So to find the inverse, we just have to switch the x and the y. So remember, I want to think about f of x as being y. So when I rewrite, now it's going to say x equals 0.5 y squared. And to be able to really state the inverse, I need to get y by itself. So first I'm going to just change where this is. 0.5 y squared equals x. All I did was flip the order. Also, 0.5 is 1/2, so I'm going to rewrite it one more time. 1/2 y squared equals x. Now I want to get rid of the 1/2. To do that, I'm going to multiply both sides by 2. So those cancel. Think about what we just did, eliminating denominators, right? So I've got y squared equals 2x. And then you all know to undo squared, we take the square root, which then is going to leave us with the equation that says y equals the square root of 2x. And we could even write that one more time a little bit better, we're going to write it as the inverse function, f of negative 1, x. So the inverse function, that's how that's read, equals the square root of 2x. And I want to show you what the graph of that, well, actually, let's talk about domain and range first, and then I'll show you the graph. So if I consider this, if I want to say my domain, I have to think about what type of numbers am I allowed to plug in for x. And you know, if I want real numbers, I cannot put any negative numbers in there for x, which means x has to be greater than or equal to 0. And then our range, this one you won't know. You have to know how to do this on your own, the domain part. The reason it's greater than or it has to be my positive numbers is because I cannot take the square root of a negative number. My range then is going to give me values that are going to be all real numbers. I'm going to put a little star next to that. We can talk about that a little bit more specifically here in a second. So take a second to look at this graph, and I'm just going to trace over it so that you can see. My first function, my original function, is shown here in blue. All right, that's going to be my just original x squared function. And when I find the inverse, and we're going to use our calculators to graph these tomorrow, notice what's happening with the inverse. If you can see, they've got a reflection line here. These two become like opposites of each other, which is why they're called inverses. So I just want you to recognize that pattern and know anytime you put it in your calculator, we're going to see this same reflective pattern both times. All right, let's look at one more example. Okay, so let's start in the same place. I want to name my domain and my range for my original function. If we used a calculator, you would notice that both of those are all real numbers. All right, so let's now find our inverse. So I'm going to say I need to switch my x and my y's. Remember, f of x is like where the y is right now. So now my equation is going to read x equals y to the third minus 9. So if I'm trying to solve for y, let me just rewrite this so that y is on the left. I'm going to add 9 to both sides, so y cubed equals x plus 9. And then to undo cubed, we take what's called the cube root. All right, cube root. Make sure you write the little 3 in there or it's not going to be the same thing. So I've got y equals the cube root of x plus 9. If we graph that in our calculator, you again are going to see that the domain is all real numbers and the range is all real numbers. All right, so here's our original function. If you notice on the graph, I went ahead and graphed our original function. And now I'm going to graph our inverse function. And remember, you should see a line of symmetry about how the two of these are related. So we're going to look at that. All right, so there you go. The two things you should be able to do, you need to know what notation is for inverse so that you recognize it in your work. And then you also need to know how you find an inverse when you're working. So make sure you know those two things before you say you're done with the video.